Good morning. Happy Diwali to all of you. Best wishes. The topic we are taken today, isomerism. So isomers, you people know very well, various definitions, chemically different molecules with identical composition. The composition may be identical, but different geometry is there. For example, glucose and fructose. You can see here the carbonyl carbon, the oxygen as aldehyde group is at the first position. Oxygen as keto group is present at second position in glucose and fructose respectively. So they are isomers of each other, chemically different compounds with identical composition. Composition दोनों की यही है. Now this important statement, biological properties of a biomolecule are determined not by their composition but by their geometry. So the properties of these two compounds are different and they are referred to as positional isomers because differ in position of the functional groups. Functional group at C1 and at C2. Two other types we are going to discuss apart from this positional: geometric isomers and optical isomers. Geometric isomers differ in arrangement of substituents at a rigid portion of a molecule. Now, this is glucose. This carbon skeleton, this is the rigid portion. And these lines are showing position of hydroxyl group. So many different isomers are present, geometric isomers, which differ in arrangement of the substituent groups, hydroxyl group precisely, at the rigid portion of the biomolecule. And optical isomer differ in optical activity. We are going to see later. Geometric isomers. The various types are there, often confusing, overlapping term. The rest of the lectures, I will try to get meaning out of each and every term and to extricate them from one another. That will be my aim. To understand these various type of geometric isomers, it would be necessary that we understand this term asymmetric carbon. What is asymmetric carbon? Asymmetric carbon is the one which connects with four different chemical groups. For example, that is also called chiral carbon. Simplest monosaccharide, OH, H, CHO, CH2OH. So four different groups are at four different valency positions. So this is an asymmetric carbon atom, the C2. Here, numbering actually what I mentioned, numbering also always starts from the most oxidized carbon. So anyway, so this is asymmetric carbon. Now, second statement, the groups attached to asymmetric carbon can be arranged to form two different isomers that are mirror images of each other. Let us see if the OH comes on this side, H here. So these two are mirror images of each other. All right. So this is called L form. This is called D form. So these two mirror images of each other, they are also called enantiomers. Now, for example, in case of glucose, let us examine both these, asymmetry kaun sa hai? This is the second, third, fourth, fifth. You can see that these four, each of these four attaches to a different, at the four valency position, different substituents, so asymmetric. This one is not because two valency positions are by oxygen. This one also is not asymmetric because two valency positions are occupied by hydrogen. So glucose has got four asymmetric carbon atom. ग्लूकोज का डी कौन सा होगा, एल कौन सा होगा, एल फॉर्म कौन सी होगी? In glyceraldehyde, it was very simple. because there was only one asymmetric carbon. Here there are four. So we consider the asymmetric carbon atom which is farthest from the carbonyl carbon. So here it is fifth. So fifth को अगर आप देखो, it is matching with the this form, D-glyceraldehyde. So this is D-glucose. This one is matching, the mirror image of this is matching with the L-glyceraldehyde. So this is L-glucose. D-glucose, L-glucose, the mirror images of each other. So designated as D or L based on position of the hydroxyl group farthest from carbonyl carbon if it is matches D or if it is matches L. Important point here, all the sugars, monosaccharides in our body, they all belong to D series. D-glucose, D-fructose, and all the enzymes, they act only on the D form, not on the L form. All right. So we have considered these two, D and L. They are also called enantiomers. And as we found that enantiomers, the D and L mirror images, they do not differ from each other in chemical or physical properties. Now we come to the other geometric isomers, stereoisomers and epimers. Stereoisomer, it is actually same chemical formula but different in position of hydroxyl group on one or more carbons. For example, here you can see one or more carbon. I'm going to elaborate. This is glucose and this is galactose. Everything same, but at the fourth position, hydroxyl group की position बदल गई है. Glucose and mannose, everything same, but at the second carbon, hydroxyl की position बदल गई है. So this is glucose. You can draw yourself. In case of galactose, at fourth carbon, hydroxyl is at a different position. In mannose, at the second position, it is at a different position. So these three are stereoisomers of each other. So one or more carbon atoms. So if they differ in only one carbon atom, then we call them epimers. For example, glucose and galactose only around fourth position. So they are, of course, stereoisomer to hai. They are epimers of each other. Glucose and mannose only at the second position. So they are epimers of each other. But are galactose and mannose epimers of each other? They are stereoisomers. But are they epimers also of each other? Try to answer this question. So हमने just अभी देखा कि स्टीरियो आइसोमर्स, अब जैसे फॉर एग्जांपल पोजीशन कुछ भी हो सकती है, lot many changes are there, are possible. So how many stereo isomers of glucose are possible? That is given by number of asymmetric carbon atom in case of glucose 2 raised to the power 4, 2 दूनी 4 4 16 are possible. Epimers, I repeat, are stereoisomers that differ in position of hydroxyl group at a single, only one asymmetric carbon. So stereoisomer, that's a broad term, one or more. Epimer, narrow, the position differs only around one carbon. Now we still narrow it down and we introduce one term called anomer. Anomer be only at one carbon and that one carbon has to be C1. Let us see. But we will have to understand that anomerism occurs only in the ring form. अभी तक हमने देखा था ग्लूकोज का CHO, OH at various positions. अगर रिंग फॉर्मेशन हो जाए, कैसे होगा रिंग फॉर्मेशन? लेट अस सी. यहां पर आई विल टेक अ बिट longer to explain this. This is C1 and this is C5. spontaneous reaction can occur between C1 and C5 like this. And a six-membered ring can be formed. So in solution, ring structures are formed by spontaneous reaction between aldehyde group with one of the hydroxyl group. Aldehyde group with, sorry, one of the hydroxyl group. One of the hydroxyl group. So the six-membered ring is formed called pyranose ring. And as you can see, oxygen that was on C5 has become part of the ring. Oxygen which was on C5 has become part of the ring, and here at C1 an OH group is formed. So now a six-membered ring is formed. Six-membered ring is formed. We have seen this OH has become part of the ring. Most importantly, the C1 has become asymmetric because now you can see it is attached to four different substituent groups. So C1 has become asymmetric. You can see here, I will explain here. C1 has become asymmetric. All right. OH हो जाएगा ना? OH. It is attached to four different groups are there. So two anomeric forms are possible. You can see here, this form, अगर OH ऊपर चला जाए, then it will become another form. So OH ऊपर चला गया, H नीचे. So these two are called alpha and beta form respectively. So we have considered about six-membered pyranose ring form. So the full name is now D-glucopyranose. It can be in two forms, alpha form and beta form, which are anomers of each other. So अभी हमने ये देखा था, it has become now OH. So OH यहाँ भी हो सकता है, OH यहाँ भी हो सकता है. The two are anomeric forms of each other. Likewise, in case of fructose, a ring formation can occur in a different way. This is fructose anomeric at the second position. So this will condense with the C5. This will be a 5-carbon ring. You can extrapolate it yourself. So this ring is called furanose ring. Everything else is same. So this is the state chain ring formation. This is called Fischer projection. This total cyclic form, this is called Haworth projection. And this is called chair form, which is closest to the natural. Why we are studying this ring structure? Because these are the predominant forms in solution. As we said, only 1 in 40,000 glucose molecule is in the open chain form. Open chain, rest is all in the ring form. And in the ring form, anomeric carbon, two anomers are possible. So we take a break now, a pause rather. T and L enantiomers, they have got identical physical chemical properties, the mirror images of each other. Stereoisomers, a broad term, differ in position at one or more carbon atom position of hydroxyl group. Epimer narrow at a single, differ in single. If it is at C2, it is mannose. If it is at C4, it is galactose. We have seen anomers, they still constriction is there. At C1, they differ, and that also in the cyclic form. So alpha, beta forms, unlike stable epimers. Epimers are stable form, chemically different compounds, glucose, galactose, mannose, different. But anomers, they interconvert. Alpha, beta, दो forms हमने देखी थी. They interconvert into each other. अगर equilibrium होगा, तो चलो anyway, So interconvert, that is called mutarotation. Supposing if you take only alpha form in a beaker, gradually in 2 to 3 hours, some portion of alpha will be converted to beta. So about, I think, 66% alpha रहेगी, 34% beta. But don't be obsessed about these figures. So this is called mutarotation, interconversion of alpha and beta form. Optical isomers, I'm sure you people already know from the school. Optical activity, rotation of the plane polarized light in right or left direction. So if it rotates in the left, it is levo. If it is right, it is dextro. And equimolar, do not rotate any light, that is racemic mixture. And this also depends upon this optical activity, like stereoisomerism, depends on presence of asymmetric carbon. So wish you happy Diwali once again. And there are certain terms, for example, I purposely omitted, but you can read with this understanding. Diastomer. Find out. Diastomer, I think, all stereoisomers except D and L, they are called diastomers, but don't be obsessed much about it. Thank you so much. Thanks a lot. And happy